Hi everybody, and welcome to the first episode of Projects with Pete. I'm your host Connor Dobson, and this is Peter Milne, an engineer with a knack for Linux and a passion for single board computers. And today we're diving into the world of industrial IoT solutions. So in this series, we're going to take a deep dive into the industrial automation world and how single board computers like ROC fit into the industrial IoT landscape. So they have the ability to perform many of the functions required to make up smart industrial automated systems, and we're going to take a deep dive into those today. So Pete, it's great to have you here today. So can you walk us through the project that we're going to be tackling today? So how does building a secure MQTT edge gateway align with industrial needs?
Well, I've set up a whole series of projects that try to showcase how ROC fits into the industrial IoT landscape. And really the centerpiece of that is we've chosen MQTT as the protocol to link all the devices together. So we've done a series of projects that showcases the ROC, the DebX, Arduino Pro, some RS PLCs, RS Pro PLCs, and how we link all those together and talk to them using an MQTT network, and a broker to transition between MQTT protocol and things like Modbus RTU, Modbus TCP, Bluetooth Low Energy, that is used as standard protocols in industrial network systems.
Okay. So I guess my first question is, so the ROC 4 SE board, it could be considered, a board for kind of tinkering for makers. So why did you choose the 4 SE for your MQTT gateway? What features make it suitable for industrial applications, would you say?
Yeah, well, there's a whole series of ROC boards really, and so you can make your choice. But one of my favorites is the ROC 4 SE. So this is one here. This has got an NVMe extension hat on it, so that I've got a solid state storage on it. But it's a really flexible board, so it's got several nice features. First of all, it's got the ROC chip RK3399T processor, and that's got 6 ARM Cortex cores in it. So it's quite a powerful little processor in this credit card form factor. But the thing I like about it is the flexibility around the storage capability. So you've got SD card slot, so that you can develop stuff. You can flash SD cards really easily, put your operating system on when you're in the development phase. Or on the back of it, there's, I don't know if you can see it, but there's a little slot just there.
Yes.
There's a connector for eMMC memory. So once you've done your development, rather than use a very fragile SD card, you can move everything over onto the eMMC memory, and you can there's different modules they clip on, and they're available up to 128 gigabytes. So that gives you a industrial strength storage solution for your operating system. Plus, you can also add on the NVMe storage. So this board's running it's running an MQTT server, it's running an Infomix database, and it's running a Grafana visualization instance as well. So it's all running on that solid state drive, and they're available up to, I think it's 512 gigabytes.
Oh, brilliant.
So you've got really flexible, it's a powerful board, a lot of flexibility around storage, which makes it suitable for industrial applications. You've got a cooling solution, so you can fit a fan to it, and also you've got a real-time clock connector there, which is important for certain applications. And this is available with 4 megabytes of RAM as standard. I think if you want a different configuration, I think OKdo can manufacture those for you if you're doing it in volume. So there's some flexibility around their services there. So it's a really solid board, and I mean, I've been running this one for over 6 months on my network. It's the first time it's been powered off, and it's just been running flawlessly, doing all those services for a whole load of sensors in my house, just ticking along there, ultra low energy costs. It just costs a few pence a day to run, very low power consumption, but a really high throughput. You can get thousands of messages through this a second on an MQTT broker. It's quite amazing, really, and you can scale it out as well. If you're developing your own network, you might have, say, 10 or 100 of these in your network with loads of sensors connected to each one. You could just keep scaling them out according to the amount of work that you want to do on it.
Brilliant. Yeah, so I guess the kind of key takeaway from that is, not only is it in a familiar form factor, it's a flexible board, but it also has the option of having that industrial reliability with the eMMC that is really key for applications like this, isn't it?
Yeah. So it's an off-the-shelf product. You haven't, if you're using a CM module, you've got to develop your own board. If you want to add eMMC memory or something like that. Whereas this has got it all built in. You can just use it as it is, and so it's great for prototyping, and it's great for building your own networks if you want, or it's just good for if you want to learn about MQTT and these industrial protocols. They're so low cost. You can just buy them and set these up. You can follow the projects that we've published, and get that really deep understanding about how this stuff works before you go out and buy expensive commercial systems. It can give you a real good insight into how, if you build them yourself, you really understand how they work, and that can help you make better decisions in a business scenario as well.
Brilliant. Okay, so you mentioned the projects that we're talking about in this series we've published on OKdo.com. So the idea of this video series is to delve into them a little bit deeper and just explain some of the kind of reasoning behind why you've opted for the board you've opted for, and the process of actually setting up, for example, the MQTT server. So one of the things I wanted to ask about is when setting up this MQTT server on the 4SE, you utilized a custom Debian Bullseye build. Is that correct?
Yes. So we wanted to show how you can build your own system. So the Radxa boards, the ROC boards, they have great support for Linux. So there's a standard Debian distribution that you can just flash onto it from Radxa. And obviously that's got a whole load, that comes with a whole load of stuff that you may not want to use in your network. And so you can choose to build. They've got a build tool, Radxa supported build tool, which allows you to build your own version of Linux based on Debian. And so you can customize it, and we showed how to do that. And also, if you want to add your own hardware, if you want to attach your own hardware, you might want to build a device tree overlay for that hardware. And so we've shown how to an example of linking a fan and controlling a fan using a custom device tree overlay in a custom Linux build, and implemented on the board. So you've got lots of flexibility there about adding extra peripherals to the board through the GPIO connectors that are on the board.
So Pete, I wanted to delve a little deeper really into why you've opted for MQTT as the broker. So can you shed some light on why you've opted for that and what advantages it has over other options?
Yeah. Okay. So MQTT has become the industry standard for IoT networks, really. And it's been around since about 2000. It originated with a guy called Andy Stanford Clark and Arlene Neiper, and they worked for IBM. And they developed, they were trying to transmit data across networks. And they've developed this as a very lightweight protocol. So it can run on loads and loads of devices, even really tiny microcontrollers. And it's become an OASIS and ISO/IEC standard. So, it's a protocol that can talk to lots of different bits of hardware, really. So it's really useful. Very lightweight, doesn't take much bandwidth. So you can send, literally millions of messages over networks, without taking too much bandwidth. And you can also, create gateways that transition between the MQTT protocol and say something like the industrial Modbus protocols. So there are lots of libraries available. There's lots of open source code that allows you to, relatively easily in languages like if you can write in Python or C++ or Go or Rust, Java, all those languages support, creating clients that can then communicate with a broker that's running MQTT. So it's, pretty easy really to set up the links. MQTT is a publish and subscribe protocol. So if you've got a sensor that's, measuring whatever temperature, that can send its temperature readings to the MQTT broker, which is, a central point. And then you can have other devices which are subscribed to that broker. And so every time the sensor sends its temperature reading, the broker then sends that information out to all the devices that are subscribed. So a single sensor can can transmit its information through the broker. So it's a one-to-one connection to the broker. But that broker could be linked to thousands or hundreds of thousands of other sensors distributed around the world even. Yeah. And they will all get that message, in a very, very short amount of time. So it allows you to scale out. You could have lots of sensors sending information in and lots of devices listening in for that information. And the broker is the central point that coordinates all that activity. So it's a key part of that network. So, you'll send, we've shown in the projects how we can send data from BLE over BLE from a wireless sensor through to a PLC via MQTT, and that's managing the transmission of all the data.
So security is paramount with everything now, but particularly in industrial settings, but especially when you're transmitting data over a server. So can you explain a little bit more about secure MQTT and how we can utilize that to ensure that everything is as secure as it can be?
Yeah. So we've just described how we did the testing with anonymous clients. So once you've done that, you can now go on to secure the network. And in the project, we've shown how to set up your own certificate authority to sign TLS certificates. And what that means is it allows you to ensure that when a client goes to connect to the broker, the client needs to know that it's connecting to an authentic broker, to the right broker. So when you log into your bank, you want to make sure that you're really talking to your bank before you send them any private information. So it's the same concept. So the client first of all needs to know that it's asking for a connection to that specific broker, and then on the broker side, when it gets a request from a client to connect to it, it wants to make sure that it's a authenticated client that's trying to connect, not just anybody, so that you don't get bad actors connecting to you. So the TLS handshake helps to ensure that, and the certificate it's implemented through or you can add certificates to it to create a chain of trust. So the certificate authority, you can set up your own to create your own self-signed certificates, which is great, for just working within your own network. But there are also commercial organisations that can generate those certificates for you if you're communicating with external third parties. But we've shown, it's the same concept, and we've shown how to set up your own certificate authority. So you do that on a secure, separate computer, Linux computer. And what you do is you create a certificate file, which you then install onto the broker, and you install that same file onto each of the clients. And so when you upgrade your system on your computer, you've got a certain certificates built into it. So companies like Google and Firefox and people like that, you know that you're talking to the right services through those certificates. And so you embed these onto the device, and then when you apply to you send a file, you upload a file to the certificate authority, and that then signs the certificate, and you then get the two keys back. You get a private and a public key, which is installed on the broker, and it's installed on each of the clients. And during the handshake process, the client only sends its public key to the broker, and the broker only sends its public key to the client. And because each of those have got their own key pairs, they can authenticate themselves, and they can validate that that transaction is authenticated, and that ensures that people are communicating, the client is communicating with the right broker, and the broker is communicating with the right clients. And then the whole thing is then end-to-end encrypted. Once that client is connected, all the data that's sent over that connection is encrypted end-to-end, so that nobody can sniff that data and decode it. But it's quite complicated, but we've gone through the steps, and we've got some diagrams in the website that tries to explain that. And it's a useful exercise to go to. There's an overhead of running your own certificate authority, because you really don't want your certificates to last for a terribly long time if you want a really secure system. So you've got to keep generating these certificates, and that's where you perhaps, if you're using in a production system, you'd use a third-party certificate authority, which you have to pay for the certificates. But if you generate them yourselves, it's free.
Thanks, Pete. Really appreciate you sharing your expertise with us today. So it sounds like setting up a secure MQTT broker is the first step towards revolutionizing industrial automation, and it's something that we're going to be delving deeper into throughout this series. So to all the viewers who have watched today, thank you very much, and stay tuned for more exciting projects with Pete. And until next time, happy hacking.
Thanks. Bye.